Hello and welcome to a new episode from Ken Training. What we're going to do today is I'm going to go over kind of like a classroom style environment in which I recently did a generator project at my house, and I almost made a bad mistake that I'm going to hopefully bring an awareness to you guys out in the audience so that you are aware of this and that you don't potentially make this same mistake as well. So with that, I'm going to try to give you the greatest content in the shortest time frame possible. All I ask for you to do is to smash that like button down for me right now. And with that, let's go on with the show. All right, so the title of the video is Don't Make This Costco Generator Mistake and Burn Down Your Home. So here is the generator that I did purchase, and I ended up returning it. I got a killer deal on it of only $590 or $600 rounded out, and because it was on sale from $800 in this inverter generator. And I thought it was a good generator at a good price, and I bought it. And then the way that I was going to use the generator was that I was going to use it to power my house. Now, let me go through this presentation. The way to use this generator is you're supposed to have the generator and use extension cords and go directly from the generator to the load. If you do it this way, you're okay. This is the acceptable way to use the generator without having any incident or any problems or anything like that. If you use this generator or any generator with this type of a strategy where you're just going to use extension cords, you'll be perfectly fine if you go directly from the generator to the load that you're trying to power. Now, if you are like me, one of the things that I wanted to power during the times when my house loses electricity is I wanted to power the refrigerator. Well, to power the refrigerator, you got, this is not me, this is just something I pulled off of the internet. But to power the refrigerator, you gotta lay down some type of flooring to protect your refrigerator being pulled out, because I also have wood flooring in my kitchen. And it's a major, major hassle. And not only that, when you have the refrigerator out like this, it blocks a large opening, because I don't have let's just say a huge kitchen. So this is a major inconvenience. So I did not want to use this strategy, the extension cord strategy, during the times of a power failure in an effort to power my refrigerator. And powering the refrigerator to me is one of the most critical portions that I don't want that food to spoil, go bad. I want that the products in that refrigerator that I already paid for, brought home and put into the refrigerator to stay good. Okay, this here is a panel found in a lot of residential homes. And at the top of the electrical panel, you're going to have the feed conductors, which is the incoming power right here on these two phases. Now we're going to call the phase over here phase A, obviously, because I have it labeled phase A, and this one is phase B. Now, when you're looking at your breakers inside of the panel, you're going to, the way that the panel manufacturer is going to do it, they're going to have the top left-hand breaker be phase A. Actually, both top breakers are going to be on phase A. The next breaker down is going to be phase B, and they just continually stagger that. So that way, when you have a two-pole breaker, like you can see here and right here, that is going to cross two phases. One is going to be phase A and one is going to be phase B. All right, and the reason why that's important in order to split your loads like that is because that way when you have something like this, where you have a device that's going to be using 250 volts, you're going to need to get that voltage differential. So in this particular case, we would say that this line over here would be phase A, which is going to be connected in this case to the X. And then this one over here is going to be phase B. And that is how you're going to get your 250 volt differential. And then the neutral wire, which is this white wire coming up here to this, well, then that is going to give you 125 volts going from neutral to hot going this way. And that is how you get all your different voltages in your home. You're going to get 125 volts or 250 volts. These are nominal voltages. Normally it will be closer to like 120 volts and 240 volts. But these are the nominal voltages that are provided here. All right, so now we have a good understanding on why you've got your different voltages and what's going on inside the panels. And then what I did over here is I counted all of the different hot legs coming out of the panel. So in this particular panel, there are 20 hot legs going down here and going down here. Now on this page, I've taken and counted all of the white lines, which are the neutral lines. There's one there, and you add them all up and you add up to 15. Well, that gives you 20 hots, 15 neutrals, and I'm not including these two-pole breakers because they cancel themselves out, okay? And then what that means is that you're going to have 5 of these hot legs circuits are going to be considered a multi-wire branch circuit, MWBC. And it is a wiring technique that shares a single neutral conductor between multiple branch circuits. This is also known as a shared neutral circuit, common neutral circuit, or Edison circuit. Now down here, you can see this is what the circuit would normally look like. You're going to have phase A and phase B. This would be one breaker, and phase B would be a separate breaker. Phase A breaker would come down here, and it's going to feed, in this case, these top receptacles or outlets. And then phase B is going to feed these bottom receptacles or outlets. And the black line here is going to be your common neutral line. Now, let me show you an example of how that works on the next slide. All right, this is the way it's supposed to work when you have the common neutral circuit. You're going to have phase A, phase B. I've got an example right down here so that on phase A, for these top outlets, you're running 16 amps. On phase B, on these bottom outlets down here, you're going to be pulling 12 amps. That's going through the breaker. But on the common neutral circuit, you're going to have the amperage imbalance, which is going to be 16 minus 12, which is only 4 amps. That is what happens under a normal situation when you've got 2 different phases of electricity running with a common neutral wire. Now I'm going to share with you what happens when you somehow do something different. This is what you are not supposed to do. So in the example that I'm providing is going to be so that you're feeding both phase A and phase B with both the same phases of electricity, which is just phase A, which you would do with that Costco generator because there was no 240 volts. There was only 120 volts. So if you were to hypothetically feed both of those legs with electricity, which you could theoretically do, in that case, you are going to overload your common neutral circuit. Let me explain how that happens. This is how it happens. On phase A, you're going to have 16 amps. On the other phase, which is also phase A, so the second breaker running also phase A, is going to be running 12 amps. Well, instead of the smaller amps canceling out the larger, a portion of the larger amps, it's going to be added to those amps. So it's 16 plus 12, which is going to equal 28 amps. So this common neutral circuit right there, that wire right there, which does not have a breaker, so it's nothing's going to cause that wire to trip or anything like that because there is no breaker in between there and the panel, but you're going to be running 28 amps on a wire that was never meant to have more than 20 amps. Technically speaking, they don't even run at rated load. So normally you even back it off a little bit of that. It's 80% of rated, which would be 16 amps. But for our purposes of our calculations, let's just say it's the full 20 amps. and then we're making an assumption that both breaker A and the other breaker A are both rated at 20 amps. So you could theoretically have a combined total of 40 amps on this common neutral circuit on a conductor that was never meant for that type of amperage. So what you're going to do is you can create a house fire, a house electrical fire. And this is why this is so important. If you do this type of a situation, you have just overloaded the shared neutral without overloading the 20 amp breakers, and this can cause your electrical house fire. This is the part that I'm trying to tell you that is critical, that you do not want to make this mistake. I hope so far you're enjoying this video. Smash that like button down if you haven't already. Thank you. The reason why I grabbed an electrical panel off of the internet instead of using my own house panel, which is pictured right here, is because you can see how congested my panel is. You can barely see the neutral bus bar. The conductors are up here and it's just a spaghetti mess. So I didn't want to have you endure looking at my own personal panel. All right, now here is the situation in which you could use this generator feeding that outlet right there, and I have it blown up right here, which is a NEMA TT-30R. And if you used this adapter right here, what can happen is this adapter has one ground leg, one neutral leg, and one hot leg. This one hot leg would feed here, and it would come over and feed this leg here. So you're coming in with one hot and you're feeding both of these hots on this outlet right here, which would be an L1430R, okay? And then if you were to take this setup with this generator, and then you were to go to use this cord right here, then you would use this particular 30 amp generator power inlet box, and this would feed your panel. If you were to theoretically do that, this is how you're going to create that phase A and phase A situation on your electrical panel, in which that was never meant to happen. You want to have phase A and phase B be completely separated. So this is how you can get yourself into trouble and hot water if you were to theoretically do that. Now, one way that you could potentially save yourself from getting yourself into hot water is when you go to wire this box in, if you were to theoretically do this, and you wire it into your panel, you would wire it in so that you are only feeding phase A or only feeding phase B on your electrical panel, leaving the other panel completely, the other conductor or bus bar completely dead. If you were to do that, then if your panel did have common neutral circuits, it wouldn't matter because you would only be using either phase A or phase B of your electrical panel. You would not have a situation where you would over amp a neutral conductor, a common neutral conductor. So then the limiting factor of this situation would be the generator itself, the rating on the generator, if you were to do that. One of the drawbacks with that strategy is that you're only going to be limited to either your A breakers or your B breakers. Now, in my case at my house, two things that I absolutely wanted to power, number one was the refrigerator, and number two was the microwave, which in my case is a built-in microwave, not a plug-in. So it's a little bit of work to remove it from the wall. So in my case, I wanted to power both phase A and phase B. So bottom line is, for my application, there's no way that this generator here was going to work. I did purchase a generator closer to this size right here. I'm going to show it to you right now in this presentation. And I'm just trying to explain to you the things that you're trying to avoid and how I almost got myself into hot water, and I don't want that to happen to you. Now, let me show you what I ended up doing. I ended up installing a generator interlock switch. This is a picture of a generator interlock switch right here. And with a generator interlock switch, because of this slide bar mechanism right here, you cannot have the main breaker and the generator breaker closed at the same time. This bar right here prevents this generator breaker from being closed when it is in this position, when the main breaker is on. When you take the main breaker and go this way to shut it off, you can slide this sliding bar up, allowing room to take your generator breaker and close it. That is how you can make your system idiot-proof to prevent backfeeding electricity back into the utility company's electricity, potentially killing a line worker, because you can never do that legally. All right, so this is the generator I did end up purchasing off of eBay refurbished, and I ended up paying a price close to $523. And I'm going to show you a picture of my actual generator, but it came with a 2-year warranty, and it looks just like this, except it's not blue, it's kind of black, and I'll show you that color coming up right now. This here is the generator interlock switch that I did get off of Amazon. By the way, I'll leave links down below for all the stuff that I purchased for my installation, just in case you want to purchase the exact same setup for your installation. Now, I did end up getting a 25-foot cord, and the cord that I got has a rating of 50 amps. So I ended up going with everything 50 amps for my installation. And here's the outlet, so the power inlet box, RV mate here, and it is, again, it's rated at 50 amps. And I also put a meter on my panel, so this way I have it connected, this conductor over here, I have this connected over on one of the generator legs going to the panel, so this way I can monitor how much watts of electricity, at least one phase A, is using, in my case, of electricity. All right, here's a picture of my actual generator right here. You can see how it's kind of a grayish color. They didn't send me a blue one, which is fine. But the generator, I unboxed it. It's like brand new. It does have an hour meter on it, and the hour meter is at 0. So, I mean, there's the hour meter right there. And it is just like a brand new generator. Now, it has many outlets down here that are available to me, but the one that I'm using is this 50 amp outlet right here. So this one here is how I'm connecting the generator to my house with all those components that I showed you. Now, this particular generator is a tri-fuel generator. So you have the ability of using gasoline, propane, or natural gas. Now, I'm choosing to use natural gas because the house has natural gas. I put a quick coupling on, quick connect coupling, and it just makes it super, super easy for me to do this. So on mine, this is the natural gas and or propane, but I'm using it for natural gas to connect onto the house's natural gas supply. And this is how much power this generator can produce with natural gas. So I can go up to 5,500 running watts and when I'm using the generator to power the house. All right. Here is a picture of the quick connect coupling that I'm using for the natural gas right at the gas meter of the house. There's the electrical service panel with the meter right there. And there's that 50 amp power inlet box that is using to feed the service panel from the generator. Now I have 2 cords right here. I've got the power cord that you can see right here. This is the one that's going to connect into that 50 amp power receptacle at the generator itself. And then this gray line here is the natural gas. This line here is going to connect onto the generator, and the other quick connect coupling goes onto this portion right here. So this way I can just feed it as long as I have natural gas. Bingo, I've got a generator at the house and I don't have to worry about refilling tanks. I don't have to deal with gasoline. It's absolutely wonderful. All right, now here is a picture of my electrical service panel, and here's that meter that I installed right there. So this way I can monitor what's going on, and there's a blow up of that meter so you can see it right here. So it shows you the voltage, the amperage, and the wattage, and I've only got the that loop connected around phase A, so it's not a 100% true of the entire generator, but it's a good representation of what the generator is doing to give me an idea of how much load I've got on. I know that I'm running 242 volts. So as I turn these breakers on, so as I power up the generator, I'm going to power it up one breaker at a time. And if I see that voltage, or if I hear that generator struggling, I know to start backing things off. But I can monitor this real time as I'm adjusting these breakers right here, loading up that generator. So I can kind of keep an eye on things. Now, the 2-pole generator breaker is this 50 amp right here, and there's the interlock associated with the main breaker, which is rated at 125 amps. So when you open the main breaker, that allows you to slide up the interlock switch, and then that allows you to close the generator breaker to power on the house via the generator. So this is how the whole thing kind of works. Now, my panel's kind of funky because of this breaker that I have right here, and I could not move the generator 2-pole breaker up into this slot right here because I'm using these half breakers. So they're not full-size breakers, they're half-size breakers. If I was to theoretically move it up, both of these would just be either on phase A or phase B. That is why I had to put it in the slot that it's in right here. So that way I'm covering both phase A and phase B, 240 volts going across the entire panel. So I kind of lost one breaker. So this one here is not connected to anything. It's just a spare. And I'm not going to be able to use it because I'm saving all this entire space just for the main breaker and the generator breaker to allow me to do that rather quickly if I need to go to generator power. It's not going to be a hassle for me at all. Now, I do have an air conditioning breaker up here that I will, if I do go onto the generator, I will need to shut this off and leave it off because it draws way too much power. And on this 40 amp breaker here for the range and oven, I could possibly put that on. Yeah, I could put that on and just realize that I could only run like 1 or 2 burners off of the range top, and probably not even run the oven, just in case I needed to cook some food. So I've got some options here that are available to me. All right, so here I just wanted to show you how I am storing my generator in my garage. And because floor space is at an absolute premium, what I did is I took the lawnmower and I used one of these bicycle hanging suspension systems. You can get them off of Amazon for $20, $25. I use it to support my bicycles. You can kind of see over here one of the bikes in the picture. There's another bike right there. So I got two bicycles being suspended above this car right here. But because the lawnmower was taking up floor space here, and I don't use the lawnmower that much, I don't use it actually at all because I hire a landscaper, but I ended up using this system here so I could, because I didn't want to sell the lawnmower, I wanted to keep the lawnmower. So I just suspended it up here so I had made room for the generator. On top of the generator, I've got my natural gas hose, my electrical extension cord, and then inside of this box here, the generator came with an adapter so that you could plug in propane and use a propane tank directly to the generator. So just in case I ever wanted to use propane, I got everything I need right here. And then I kept the box that the generator got shipped in, just cut out holes for the wheels, and then put the box on top just as a dust collector. So that's my method of storing the generator and having it easy, pretty easy access so that I can set it up without any problems. All right, guys, that is going to conclude this video. I hope you got some valuable information out of this video. If you have not done so already, smash that like button down. Subscribe to my channel, Ken Training. I will catch you on the flip side.